Managing object storage for a single application is straightforward, but as an organization's footprint multiplies across hundreds of AWS accounts, petabytes of data, and billions of individual objects, the administrative logic that worked for a single bucket breaks down entirely. When dealing with millions of objects, attempting to write custom local scripts to synchronously iterate over the standard API is slow, expensive, and computationally fragile. At the enterprise scale, maintaining strict security compliance, granular access control, and absolute cost efficiency requires specialized native orchestration tools. You can no longer manage objects individually. To master storage management at this level, we have to deconstruct three distinct systems: S3 batch operations for massive state changes, S3 Inventory and Athena for columnar metadata extraction, and S3 Storage Lens for global telemetry, culminating in a granular storage class cost analysis. Surviving petabyte-scale growth requires engineers to abandon manual bucket management entirely and instead build automated native infrastructure pipelines. The first logistical hurdle is execution. Writing a custom script to modify 10 million objects means pulling down 10 million responses to a local compute instance. It creates a network bottleneck, and a single dropped connection can corrupt your progress tracking. This architectural diagram shows how S3 batch operations solves the execution problem. It allows you to perform bulk requests natively on S3's infrastructure, entirely bypassing your local compute limits. You feed a list of target objects into the managed batch engine, and it handles the heavy lifting. The engine supports a strict set of built-in actions. You can modify object metadata, copy data across buckets, enforce encryption on unencrypted files, update tags in bulk, or even invoke custom AWS Lambda functions to apply specialized logic to every file in the batch. Because S3 Batch manages the underlying tasks, it tracks the overall job progress, automatically handles retry logic for failed operations, and generates a final verifiable completion report in your logging bucket. This managed execution becomes especially critical when pulling massive datasets out of cold storage, specifically bulk object restores from S3 Glacier. This flowchart demonstrates how S3 Batch coordinates bulk Glacier restores. Instead of you writing a script that sends thousands of sequential restore object requests, S3 Batch orchestrates the pipeline behind the scenes. It automatically sorts the standard, expedited, and bulk retrieval tiers, eliminating the API overhead and throttling bottlenecks that crash manual scripts. Offloading execution to S3 Batch provides systems engineers a highly scalable, safe method for driving massive data migrations and compliance remediations without overwhelming local resources. Launching these massive batch jobs requires passing two strict validation hurdles: a properly formatted manifest and exact IAM execution authority. The manifest is simply the list of target files you want the batch job to process. It can be formatted as a CSD or generated directly by an S3 inventory report, and it must strictly contain the target bucket name and the specific object key. There is a critical edge case for bucket versioning. If versioning is active on your target bucket and you need S3 batch operations to target historical files, adding a version ID column to your manifest is mandatory. S3 applies strict checksum and schema verification to this manifest before starting. If it detects a single malformed entry, S3 aborts the execution job immediately and returns a validation error. Once the manifest passes, S3 verifies permissions. You must assign a specific IAM execution role to the job, governed by a trust policy that explicitly allows the batchoperations.s3.amazon.com service principal to assume that role. That role requires three highly scoped permission policies to proceed. It needs permission to read the manifest file, permission to execute the chosen action on the target objects, and permission to write the final completion report back to your designated logging bucket. These rigid validation and IAM requirements ensure an automated process capable of altering millions of files cannot be triggered accidentally or by an unauthorized principal. Since S3 Batch requires a manifest, the immediate logistical problem is how to efficiently generate that list of object keys when your bucket contains hundreds of millions of files. This diagram illustrates the penalty of using the standard synchronous LIST API for discovery. Because standard list queries page through only 1,000 objects per call, at 0.005 per request, mapping a bucket with 100 million objects costs $500 in list fees and consumes hours of compute time. The scalable solution is S3 Inventory. It provides a daily or weekly asynchronous alternative to the standard list API, operating at a fraction of cost. Instead of synchronous JSON responses, S3 Inventory outputs your bucket metadata into highly optimized columnar file formats like Apache Parquet or ORC. Once the metadata is extracted into these columnar files, you can query them directly using Amazon Athena, a serverless SQL engine. Because Parquet and ORC are compressed and query optimized, Athena only scans the exact columns requested in your query. This column-level targeting reduces the overall data scan size by up to 90%. The cost difference is massive. Athena charges a flat rate of $5 per terabyte of data scanned. In practice, your team can execute a select query for bucket name, object key, and encryption status. Athena will scan only those 3 columns across millions of records to instantly output a manifest of objects requiring remediation. Replacing synchronous list APIs with asynchronous columnar querying drops the cost of manifest generation from hundreds of dollars down to near zero and compresses hours of processing into sub-minute speeds. Building execution pipelines covers individual datasets, but maintaining governance requires total, continuous visibility into storage health across your entire AWS organization. AWS engineered S3 Storage Lens to provide that observability. Its critical architectural advantage is that it operates entirely through background telemetry collection. This means gathering analytics imposes absolutely zero performance overhead, latency, or query throttling on your live production buckets. Storage Lens aggregates metrics across accounts, regions, and buckets daily. The free tier maintains 30 days of history, while upgrading to Storage Lens Advanced unlocks 15 months of data, granular prefix-level analysis, and automated metric pushing into a master logging bucket. Inside the dashboard, engineers rely on data protection metrics to audit security posture. Tracking versioning-enabled bucket count, MFA delete-enabled bucket count, SSE KMSE-enabled bucket count, and cross-region replication rule count instantly flags any bucket failing to comply with organizational data policies. Access management metrics provide visibility into ownership configurations. Tracking the object ownership bucket owner enforced bucket count allows administrators to easily verify that legacy ACLs have been disabled across the environment. Performance and activity metrics reveal exactly how data is moving. By mapping transfer acceleration-enabled bucket count against API request counts and total bytes downloaded, you can cleanly map your active write-heavy ingest zones versus your read-heavy distribution points. Status code metrics act as an architectural alarm system. A sudden spike in 403 forbidden error count flags security misconfigurations and unauthorized access attempts, while tracking the 404 not found error count exposes broken application links in real time. S3 Storage Lens empowers administrators to instantly audit the compliance, security, and performance posture of hundreds of AWS accounts without putting live workloads at risk. We can apply the specific telemetry gathered from Storage Lens to infrastructure cost optimization, allowing us to accurately align data with the correct storage class. This descending bar chart tracks US East 1 pricing. If you store data in S3 Standard, you pay 23 thousandths of a dollar per gigabyte per month. Enabling standard intelligent tiering monitors access patterns to transition inactive data to cheaper tiers automatically, avoiding any retrieval fees. Moving to standard infrequent access drops the monthly rate to 12.5 thousandths of a dollar, but introduces per gigabyte retrieval fees. One zone IA pushes costs down to exactly 1 cent per gigabyte, but confines your data to a single availability zone, risking absolute data loss if that physical facility is destroyed. For archival data requiring millisecond access, Glacier Instant Retrieval costs 4 thousandths of a dollar per gigabyte. Glacier Flexible Retrieval drops to 36 ten-thousandths of a dollar, but the absolute price floor is Glacier Deep Archive. At 99 hundred-thousandths of a dollar per gigabyte, it is the cheapest option available, provided your architecture can tolerate a 12 to 48-hour delay for bulk retrieval. By auditing your application access patterns and placing cold data in Deep Archive, enterprise storage costs plunge to under $1 per terabyte per month. This architecture map shows the full operational lifecycle we've constructed. It begins at the macro level. An engineer observes a global compliance gap or cost anomaly through S3 Storage Lens telemetry. The response requires precision. The engineer uses Athena to query the asynchronous S3 inventory Parquet files, instantly isolating millions of non-compliant objects into a clean CSV manifest. Finally, that manifest is fed directly into S3 batch operations. The batch engine assumes the IAM execution role and natively migrates the data to Glacier or encrypts the files on AWS hardware, reporting back only when the job is complete. Managing S3 at the enterprise scale requires moving past manual configurations. By leveraging this automated trifecta of global telemetry, columnar metadata extraction, and native bulk execution, you build storage architectures that are secure, compliant, and cost-optimized at petabyte scale.